Lesson, we created the spaceship class, made it to move, and to respond to a user command. In this lesson, we will create a barrier manager and a separate barrier class. Now we are in the game panel, and we create the barrier manager. We create a class and add it to the game panel in the constructor. Then we will set the bitmap as the parameters. Next, we create the constructor in the class. Now, let's do the Barrier Manager class. Here, we created all the necessary variables, and we initialize our bitmap in the class. Here's a brief summary about the variables. The ship height is the height of the spaceship, and the other variables will be used at a time when we will generate our barriers and the corridor walls. The top walls and bottom walls arrays are the upper and lower walls. Then we create a setShipHeight method where we will indicate the height of the spaceship. Next, we create a setScreens method, which will determine how many barriers to draw on the screen, and will allocate them. Let's create an empty barrier class and setScreen method. So, we wrote setScreen, where we set the screen height variable and number of barriers that we can place on the screen. Let's take just +4, just in case. So we will not have any problems during the drawing. And we initialize the arrays. Next, we fill the arrays from 0 to the number of barriers in the loop. The first parameters are set to the bitmap, and the second parameters are set to x and y and width plus 200 pixels. Then we take from the bitmap width that is multiplied by I. Why do we do this? We initialize the barriers especially behind the screen areas, so they could appear later in front of the player. In addition, that would create the illusion that we are moving down the corridor. Next, we will create a set manager for our barrier and tell it that it is the main barrier manager, so our barrier could refer to its barrier manager. Then we create all of these methods within the X and Y class and create the set manager method. At the end of the set screen method, we have to generate random location barriers. Let's create a separate method for this. We created the generate method. Now we start filling it. Here we filled this method. Where do we get the h variable? We take half of the bitmap height. Then dl is a variable of the width of the corridor. dpos is a variable of the middle of the corridor. new_dl is the width of the corridor that will be the end. The width of the corridor is 3/5 of the screen. A variable inc is how much we will deduct delta L, and this is the height of the screen. This is in order to get at the end a new DL value of the corridor that is 3/5 of the screen height. Next, we take the bitmap height and set the Y value for each barrier of the top row and the bottom of the barrier. Accordingly, we create proper methods, such as bitmap and Y. We generated the first corridor, and after, the corridor will be drawn, and it will be drawn in parts. The parts that have gone to the screen will be drawn on the other side of the screen. As a result, we get the pipeline effect. Now we create draw and update methods. In draw, we indicate the canvas, and in update, we indicate delta t. Everything is simple in the draw method, and we just call the drawing that is in the array. Then we create such method in the barrier class. Well, we still have one more method to go, and this, of course, is the update method. Also, we will go through our arrays and call the update method. We will indicate dt in the parameter. Then we add the game panel to the following parameters and the constructor. Now we declare a variable in the class. As each of the barriers was given the pointer to the barrier manager, now we can easily refer to the game panel. Therefore, we are not going to pass it. We pass the Boolean variable that indicates the upper and lower rows. Then we create a method in the barrier, and thus add to the game panel in the constructor. Now all that remains is to describe the barrier class. The barrier class will have three variables, the bitmap and the x and y coordinates. In the constructor, we set the bitmap, x, and y coordinates. Next, we add the barrier manager variable in order to keep it so it would generate for us. Then we return bitmap and set y. We still have two methods left to draw an update. Again, everything is simple in the draw method. We just draw as we did the ship on the center of the bitmap. First, we set the center coordinates. Then what remains is to describe the update method. It must update the status of all the blocks, and if any of them go outside the screen, it should redraw them on the other side of the screen, making continuous streams of barriers. To keep the barrier smooth, we will be setting a random point to which the corridor will be directed, namely the vector of its direction. And when it reaches this point, we choose a new point. For this, we will create a Boolean variable and call it doIt. We've reached the target, so let's fill the update method. Here, we described the update method, and now we tell you what we have done here. First, we check if the barrier is still here. Just to remind you that if the barrier manager update occurs in a loop, namely we ask each of our barriers whether it went outside the screen. If it did, then X is less of the screen width. Just to remind you, this is a Boolean variable. If we have the top row, then it is true, and we deal with the top row. If it is false, we deal with the bottom row. Now let's explain why that is. Because first we deal with the top row, and then we set Y and deal with the bottom row. If we got closer to the target point by less than 50 pixels, then we put doIt equals true, and we need to generate a new point. We choose it from the screen area and subtract the corridor area and add a quarter of the corridor. This gives us a random number, a quarter of the corridor value, and then the screen height minus the quarter of the corridor, namely the edges of the corridor that do not go far beyond the edges of the screen. If the midpoint of the corridor is less than the target point, then we add to the center of the corridor a random value of around 15 pixels. If it is vice versa, then we subtract that. In this way, we calculated the center of the corridor, and accordingly we set Y. When we go through the bottom row, we will have the center point of the corridor. What remains is to set the value. After that, we set X, so its new position will be the end of all the blocks. Namely, we look at its current position and add the width of the block and multiply by the number of blocks. The only thing we have left to do is to increase X for a regular value. That is, when the barrier is moving across the screen. And we already know how to do it. we assign to x minus bm. Then we take the speed of the ship in the game panel and multiply by delta t. So, we are done with the barrier class and the barrier manager. All that remains is to place them on the game panel. Now, we set the width and height of the screen. We add the manager and update to the drawing. Now we'll run the application and see how the barrier will be drawn. Okay, so let's run the project. We click on Start Game. Here we see the barriers, but we cannot collide with them. To deal with that, we need to use the collision method in the ship class. Namely, we should start collision checking in the counter. To do that, we have to take the points from the array. We should get a barrier from the array and use its points, so we call the array. In order to make the array to give us these points in the order that we need to. We call it temporary equals new array list collection. Now we create a getArray method. Here we give out the array list and put the points. Next, we will only work with arrays and with the class of points. To make it short, we can take this function from the ship class. They will be exactly the same for the barrier class as they were for the ship class, because they were drawn from the center of the bitmap. So, we duplicate again our getPoint function, and we advise to take our declaration from here. So, we've declared all the points, and now we have to add them to the array. Then we create the array list point variable, and we also call it temp. Next, we initialize and add all the points in order. The order must be kept strictly clockwise. First, we do the top left, and then top right, and bottom left. Then we set the array, and we can return it. When we return the array, we must write this: temp.get0, temp.get1, temp.get2, temp.get3. As a result, our function will provide the collision for us. In addition, we need to check the same thing on the bottom row. Also, we duplicate the function, and after all the checks, we clear it. We still need to create a second array. We call it temp2. Then we compose it from our lower walls of the array. Now we combine it in one condition with OR. Here goes our first check, and then goes the second check. If it works, then we collided with the barrier. Now we tell the ship that it has crashed. Next, we will do a small condition, and we will check on a collision ourselves if the ship did not crash. If we will check when it collided, then we will be endlessly colliding with the barriers. The development environment suggests that the temp2 is not used, so we will add the temp2 everywhere. Finally, we advise you to add to the condition the background update and barrier manager update if the ship did not crash. When we collide with the barrier, then we stop the barriers, background, and the coins. Now to show that the collision works, we put a breakpoint inside of the function, and if the ship collided with the barrier, then debug stops at breakpoint. The debug is activated by a green beetle button. Now, let's start and go to the screen. There's a running installation, and our game has started. We started flying, and the program said it ran into the breakpoint, and it offers us to switch to debug mode. This is a very useful debugging tool, but now the important thing is that the program caught the collision with our barrier. Now we click on No. In the next lesson, we will create a bonus class. This is a class of coin. And also, we will make the collision reaction to the coin. It will be a positive one. When we pick the coin up, we add points to the score panel. Can't wait to see you there!